This is the Further Math Support Programme, Year 11 to Year 12 Bridging course on coordinate geometry. We're going to break up the lesson into 4 parts. So firstly, we're going to look at the midpoint, distance and gradient between 2 points, something that you have actually learnt in your GCSE course, as well as parallel and perpendicular lines. The third part is finding the equation of a line given its gradient and a point on the line. This is actually an equation that you haven't seen before, which you will be working with in your A-level course, as well as the finding the intersection of a line and a quadratic curve using simultaneous equations. The latter 2 parts, if you have done any additional mathematics in school for the level 2 qualification, you will have come across these. Okay, so first we're going to look at the midpoint and the distance and gradient between 2 points. So formula for the midpoint is here, and you've seen this in your GCSE course. Now remember, x1 with this little subscript 1, y1, x2, y2, they have no mathematical meaning. It's just a label for the coordinates. So if I have 2 coordinates, then the midpoint is the average of the x coordinates and the average of the y coordinates to give you the x and y coordinate of the midpoint. The distance between these 2 points is by using Pythagoras, so you can see the formula there and the form of Pythagoras. So in this case, just be careful, this is not addition now, we're actually working out the difference of the x coordinates and the difference of the y coordinates and passing that into Pythagoras' formula to work out the length of the line between the 2 points. And you will see shortly this in a diagram. And the gradient you've seen as well. This is the difference of the y coordinates divided by the difference of the x coordinates. Again, note the labeling. So you choose one coordinate and you then subtract the corresponding y and x coordinates from the other coordinate of the point you're given. And you can't mix and match. So we'll see that shortly when we look at an example. So these 3 you have in theory seen before in your GCSE course. So let's have a look at a line, an example. So here's A and B with the coordinates, as you can see. So if I work out the midpoint of these, good way to be quite so you don't make a mistake. Obviously you can just substitute these numbers into the formula. But what I tend to do is I tend to just quickly put a little x1, y1, x2, y2 above the coordinates that I've been given. Now, you can interchange these. It doesn't have to be in this order. I could have had my x1, y1 above the b and x2, y2 over the a. As long as you follow the same order throughout the formulae, you will get exactly the same answer. So anyway, here we are. I've labelled them. So now I just substitute into the formula to give me the midpoint here of 6, 6. The distance, so there it is. So it's all about setting up a right angle triangle between the 2 points where the actual line AB is our hypotenuse. And then the height of the triangle is the difference of the y coordinates. The width of it is the difference of the x's. And as you can see, there are the coordinates put into the formula, which gives us an answer of root 80. Leave it in surd form because that's the most accurate form for us mathematicians. We do not need to change it to a decimal unless we're asked to. And I've just added there in simplified form root 80 being equivalent to 4 root 5. Knowing that for 80 is 16 times 5, therefore I could square root that 16. So there we are, there's the answer to that. Again, you don't need the simplified form unless it's asked for. And the gradient, again, is substituting to the formula. So we've got y2 minus y1, 10 take away 2, divided by 8 take away 4, because that's our x2 and x1, which gives us a gradient of 2. So there we are, that's the steepness of that line. For every 1 unit you go across, we go 2 units up. Right, here's another line, clearly going downhill, so we would correctly assume that it's going to have a negative gradient when we come to that point. So first off, again, label the coordinates x1, y1, x2, y2, and then substitute into the formula for the midpoint. In this case, note how we've got a negative x1 coordinate, so minus 2 add 4 is 2, divided by 2 is 1, so you know the negatives, take care with them. Distance, again, is the difference of the x coordinates and y coordinates. So note the formula has a minus in it, but one of our x coordinates is negative. So because of the way I labelled it, my x1 is going to be subtracted, which is our minus 2. So we do actually have formula minus negative 2, which therefore becomes an add. So we've got 6 squared plus, now 7 take away 11 is minus 4, because we've had to follow the order in this case, y2 minus y1. So it does give us minus 4, but because we are now squaring those numbers, they become positive, which is why I get plus 16. So there we are, there's the distance. And again, for the gradient, we substitute, we've chosen our x1, y1, x2, y2, we sub it into the formula, which in this case gives us minus 4 on the top and the 6 on the bottom, because we're taking away a negative number, that minus 2, which gives us a gradient of minus 2/3. So there is our negative gradient, which is what we surmised at the start. Next, we're going to look at parallel and perpendicular lines. So if two lines are parallel, as we know, train tracks, they follow the same direction. Mathematically, it means they have the same gradient. Now, if I have given a line, the equation of a line, then to work out the gradient, remember that we have to rearrange it in the form of y equals mx plus c. So we have our y as the subject of the formula, and then the number in front of the x, the coefficient, gives us the gradient. Now for perpendicularity, which means that two lines meet at a right angle, if I know the gradients of the two lines, in this case we use m subscript 1 and m2, then if I multiply those gradients together and I get minus 1 as the answer, then I know that those two lines are perpendicular. So let's have a look at our example before. We're going to use the same line AB. So I know from the last slide that this has got a gradient of 2. So if I want to work out the gradient of the line perpendicular to this one, let's call it EF. So this meets at a right angle, so we know, we've been told it does. So what is its gradient? Well, what I've got to do is, as you can see from the formula, m1, m2 equals minus 1. To work out the other gradients, I have to divide it into minus 1. So gradient AB is 2, so minus 1 divided by 2 is minus a half, minus 0.5. Best to leave it as a fraction. But there it is, that's the gradient. So, and you can see just from the diagram as well that it would have to be a negative gradient if our AB is positive. And there it is, there is our negative gradient, as you can see. So there's that one. If I look at the other line we had previously, which is CD, so we established before that this had a gradient of minus 2/3. So in this case, again, if I want to work out the gradient of a line perpendicular to CD, in this case here is HG, but it could be anywhere along that line as long as it's at a right angle to it. Then again, I divide my gradient into -1. So I've got -1 divided by -2/3, and if I divide by a fraction, it's the same as multiplying by its reciprocal. And because I'm multiplying, so the reciprocal of 2/3 is 3/2, and clearly because I'm timesing by 1, it stays the same. And you can see that we've got a minus divided by a minus, which gives us a plus. So the perpendicular gradient to CD is 3/2. Okay, so the last technique we need to have a look at before we can have a look at some exam questions is finding the equation of a line if we know its gradient and the coordinates of a point lying on the line. So here it is. Here's the equation, which in your GCSE course you don't see, but you do if you've touched on it in additional maths. And here it is. So if I know the gradient, m, of the line, and this line crosses a point with coordinates x1, y1, then the equation of the line is y minus that y coordinate of the point, y1, equals the gradient multiplied by x minus x1. Note the brackets because it is in brackets. So there it is, that's the equation of the line. So let's use it now. So here's, again, go back to our line AB with the same coordinates. So again, we know from before that the gradient is 2. So if and then there is my x1, y1, but I could also, so here it is, x1, y1, which is point A. So if I substitute the coordinate into and the gradient into that equation, we get the equation of the line. So there it is, but any point on that line will work. So I could have chosen B instead of A because it is a point on the line. So if I substitute the 8, 10 into it, there is the equation of the line as well. Now on face value you might think, oh, they are different, but if I actually rearrange them into a particular form, you will find that they give exactly the same equation, which is y equals 2x minus 6. So you can see the 2 there, it has got a gradient of 2, and it is in that form of y equals mx plus c. And in this case, if that line continued down, if we continue to draw it all the way down, it would intersect the y-axis at -6. Now another way of all I've done is I've just moved everything over to the I've moved the y across as well to the right hand side, because sometimes they may ask in an exam, they might ask for a particular form. So you can see that if I collect the y on the right hand side, you do get an equation 2x minus y minus 6 equals 0, but they are equivalent. But the key is I could either use point A or point B in our equation, and ultimately if you rearrange you will get exactly the same answer whether you're using point A or point B. So again, here is our line CD. If I use initially, first we know again from before that this has got a gradient of -2/3. So I'm going to use point C first. So there's my x1, y1. So I now substitute it into the formula, and there it is. So there is the equation with everything put in without dealing with negatives or fractions or anything, but there it is. I can already from there, if it was in that form, I would be able to tell you everything about the line in the sense of, oh, it's got a gradient of -2/3, and I can see that it crosses the point -2, 11. Now that's why I put the label there, the x1, y1 as well. It's very easy. Obviously we read from left to right, but it's a second coordinate that you put in as your subtraction from y, and it's the x coordinate obviously in the bracket. But I do see it often where just accidentally, careless mistake, they put the x coordinate in on the y side and the y coordinate in the x side. So take care of that. That is quite a common mistake I do see. And again, to show you that if I use D and label it x1, y1 there, if I use point D, I get that equation, which again does look different. But if I do rearrange, and I'll leave that for you to have a look at, you do get the same final equation. So this one is a bit more complicated, but you can see in terms of the numbers, but you can see that this is if I rearrange it in the form y equals mx plus c, there is the gradient of -2/3, and this line crosses the y-axis at 29/3. And if I remove the fraction, so if I multiply that whole equation by 3 and collect all the terms onto one side, you get that equation, 2x plus 3y minus 29 equals 0. But the left hand one is more useful initially because you can see exactly the gradient and the y-intercept. So there we are, that's how to use this particular equation. Right, so here's an example of an exam question. So we're given two coordinates, f and g, and the first thing we've got to do is find the length of the line FG. So I always tend to quickly jot x1, y1, x2, y2 above the coordinates, and then I can easily follow which coordinate goes where into the formulae. And if I want to work out the length, I use the formula that we saw before. Substitute everything in, just taking care with the fact that there is a minus in the formula, and the coordinates we just substitute in, and there it is. Just take care with negatives. So if you were going to do it on a calculator, remember to put the -6 in brackets and then square it, or just knowing the fact that it is a negative number and all numbers squared are positive, you could have just put 6 squared there. But there it is with the brackets. That would, in a calculator, give you the right answer of 10 units. So that's the length. And then the gradient, again, now that we've labelled all our points with the x1, y1, x2, y2, I substitute the values in, and I get a gradient of -4/3. Now there is a part C to this, which is to find the equation of the line that passes through the midpoint of the line FG and is perpendicular to FG. And on top of that, the question is asking us to put it into a particular form, which I discussed with you before, which is in this form of ax plus by plus c equals 0. So once we've got the equation, we actually have to rearrange it so that we see in this particular form. And in case there are any fractions for our a, b and c, we need to deal with that as well, because we've been told that a and b and c are integers, whole numbers. Right, so there it is. There's our line. Quick sketch to see what's going on. So again, I quickly label x1, y1, x2, y2 for the two coordinates to help me. So the midpoint, exactly what I did before. I substitute all the values in, which gives me a midpoint of 110. So this is what I'm now trying to work out. It's asked for the perpendicular line that crosses at this midpoint 110. So there's two things I need. I need the gradient and I need a point on it. The point we've got, which is the midpoint, and the gradient, if you can recall, is by dividing the gradient what we do have for FG and dividing that into -1 to give us our final gradient. So the gradient for FG I've already worked out, so you now know in theory how to do that. So it was -4/3 by calculating it. So now if I divide that into 1, reciprocal of 4/3 is 3/4, and again, because I'm dividing a minus by a minus, I get a plus in this case. So there we are, there's the gradient of 3/4. So now I just substitute it into the equation we learnt before, y minus y1 equals m times x minus x1. I substitute all the values in, and I get y minus 10 equals 3/4 times x minus 1. Now, it's asking us to rearrange it and have integers for our coefficients, for i.e. the numbers in front of x and y, and the c as well, being an integer. So the way I would do it is I would now multiply the whole equation by that denominator of 4. So in that case, on the left-hand side, I've got the 4 times now, but be careful, remember that this will now be 4 times all of y minus 10, which is why I've got it in brackets. The right hand side, the times in by 4 was the whole point, because now I've got rid of the denominator, so they cancel. So I've got 3 times x minus 1, and then expanding the brackets and then rearranging gives us the final answer required, which is 3x minus 4y plus 37 equals 0. Okay, so here is an example for you to try, a past exam question. So please read it carefully, and the answer will be on the next slide. So if you want to stop the recording now and have a go. Okay, so here's the answer to question 1. Note how in part A it wanted the answer in a simplified surd form, n root m. So there it is. So you get an answer of root 164, but then you have to simplify that. So if you've followed the surd course in these sessions, you should now know how to work the root 164 out. But basically you can see that it's 4 lots of 41. 41 being a prime number, so that can't be simplified. But the square root of 4 is clearly 2, which is why you got it out there. Here's question 2. So if you want to have a go before you see the answers, stop the recording now, please. Here are the answers for question 2. If you have a look at part C, again, as I said before, we could have used either point E or D or E when we substituted it into the equation for a line, given the gradient and the points. But I've used 5, 5 simply because the numbers are simpler and there's no negatives, and just made it a bit easier. But either will work. Here's question 3. Again, if you want to stop the recording now. Answers to question 3. Here's question 4. If you want to stop the recording now, please. And here are the answers. And finally, question 5. So I'll stop the recording now. and here's a solution. Okay, so the last thing I'm going to teach you today is to find the intersection points of a line and a quadratic curve, and we're going to use the technique of solving simultaneous equations to work these out. Now, in your standard GCSE course, when you've seen simultaneous equations, you know that this graphically means that two lines meet at a point, and when you solve the simultaneous equations, the x and the y value you get is the point of intersection. Now, with a curve and a line, you have a few more scenarios. Firstly, if your line can cross the curve at two distinct points. So when you solve the simultaneous equations, you are actually going to get two pairs of answers, not just one when we were talking about two lines. So you're going to get two pairs of answers, as you will see shortly. So that's one situation that you can have. Now, if I move that line down, it will ultimately become a tangent to the curve. So that means it meets only at one point. Now, therefore, you're going to have only one pair of solutions to when you solve the simultaneous equations. Now, if I move the line even further, then clearly it doesn't cross the curve at all. So in this case, you will find when you're trying to work these out mathematically, you cannot solve them. That you come into problems depending on how you solve them. You will see that they're impossible to solve. If this situation does arise, then you know that the line and the curve don't intersect. Now, in your A-level course, you're going to be looking at this in detail, and it's to do with something called the discriminant, which is part of the quadratic formula. But all you need to know at this moment, at the start of AS and essentially in the additional maths course, is that the line either crosses at 2 points or possibly 1 point, and we do not look at the green, but this is something you will be looking at in detail in your A-level course. Now, the way to solve these, if you are given the equation of the curve, the quadratic curve and the line, the way we solve these equations is by using simultaneous equations, but it's the substitution technique that we use. Now, usually, mainly, you learn the elimination method, which is when you change the x and the y coefficients of the two equations and then you add or subtract them to eliminate one of the variables. But this is a substitution technique which you may or may not have seen. So that's what we're going to focus on today, looking at some exam questions from the additional maths papers. Okay, so here's an example. So we're going to find the coordinates of the points of intersection of the curve y equals x squared minus 7x plus 12, a quadratic curve, the highest power is the 2, and the straight line x plus y equals 4. Okay, so the first thing I'm going to do is I'm just going to quickly label my two equations A and B so we know which ones we're talking about. And as I can see here, in equation A, we've got 1y is equal to x squared minus 7x plus 12. So what I'm going to do is I'm going to rearrange equation B and make y the subject. So that's nice and simple. Just subtract the x from both sides, so leave us with 4 minus x. So now I've got y equals x squared minus 7x plus 12, and I've also got y equals 4 minus x. So because I'm solving these simultaneously, this is where the line and the curve meet, I now know that I can substitute my y equals 4 minus x into the other equation, equation A. So now I've got 4 minus x is equal to x squared minus 7x plus 12. So how do I solve this? I can see I've got a quadratic. So as always, we collect all the terms onto one side and set it so that we're setting it to 0. I normally rearrange it so that my x squared term is positive. So there it is. I've got x squared minus 6x plus 8. So to solve that equation, I factorize, and therefore I now know that x is equal to either 2 or 4. So this is what you've covered in your GCSEs when you're solving quadratic equations by factorizing. So there we are. You can see already there's 2 x values, not just one, when you're solving 2 linear equations, which is what you cover in your standard GCSE course. There's 2 now. So therefore there's going to be 2 y values. So what I do now is I substitute both the x equals 2 and x equals 4 into either equation A or equation B. But simply because B is simple, I'm going to use that one. I could equally have used equation A, but just purely for taking a number away from 4 is far easier, I'm going to use the rearranged equation B, which is the top box you can see at the top. So therefore, when x is 2, y is 4 minus 2, which is also 2. So there is one set pair of values, and they must be together in like that. So 2, 2, that's one coordinate of intersection. And the other one is when I substitute x equals 4 into my rearranged equation, the y equals 4 minus x, which gives us 4 take away 4, which is 0. So there we are. This line crosses the quadratic curve at 2 distinct points, which is from the previous slide, the top one, and they cross at 2, 2 and 4, 0. Okay, here's a second example. So here we've got the curve y equals x squared plus 6x minus 5, and the straight line y equals 2x plus 1. Again, we've got to use an algebraic method, but now it's asking us to give the answers correct to 2 decimal places. So that immediately gives the game away, and we know that we'll be using the quadratic formula at some point. So again, we start the same way. So I'm just going to label the equations A and B, so we know what we're talking about. And as before, we put the 2 equations together. Now here, the difference with this question is it's already y equals 2x plus 1. So we've already got equation B with one of the variables, in this case the y, as the subject of the formula. So immediately I assign the 2 equations together. So the 2x plus 1 equals x squared plus 6x minus 5. So again, exactly as before, we rearrange so that the equation is equated to 0. And you will probably see that you start factorizing or attempting to factorize, and you can see that it's not going well. But the thing is, because it's asking for 2 decimal places, you know you've got to use a quadratic formula. So there it is. Now at this point, we are not given the quadratic formula, and we'll probably still be asked to show some workings, so we do need to remember the quadratic formula. Obviously some of the newer calculators now don't require us to actually use it explicitly. We can just put the A, B and C in, but we do need to show some sort of working. So here it is. So there's the quadratic formula. I know that A is 1, B is 4 and C is minus 6, looking at our quadratic equation. And then by substituting into the formula, we get the 2 values for x being 1.16 or minus 5.16. And again, I substitute these 2 values in to the simpler equation, which is equation B, to give us the corresponding y coordinate for our 2x coordinates. And there it is. So I substitute those values in, and work them out. And in this case, we work out that the two coordinates are the following. So there they are to 2 decimal places. Okay, here's question 1 for you to try. Stop the recording now, please, if you don't want to see the answers. Here's the answer. And finally, here's another one for you to try. Stop the recording now. And here is the solution to the question. And that's the end of the session on coordinate geometry. Thank you. Diolch yn fawr.